Hi class, it's me, Mr. Morris, and I'm making another video on notes for AP Chemistry. This is talking about the difference between ionic and covalent compounds, and it's a review of pre-AP Chemistry, but we go into a little bit different details, a little bit more details, and it's a useful review. Also, I wanted to use this opportunity to show you at least one of the ways that you can take notes this semester if you don't have a printer handy. So you can, most of the time I'm going to give you a Google Doc that you can just type into. And I'll show you a couple shortcuts that you may need at some point. So let's get started. First of all, we're talking about ionic compounds. This first column is ionic compounds over here, and covalent or molecular compounds over here on the right. So what's the name for one unit of an ionic compound? Well, we would call that a formula unit. It's not something, that's not a word that we use all the time. Not very frequently used in everyday life, but that's what we call it. One unit or one particle of of an ionic compound is called a formula unit. So another word for the name of the unit would be, also we could say it's the name of the particle. And then for a covalent or molecular compound, we would call that a molecule. Molecules can also be referring to a diatomic element. All right, now the attraction within the units, and by the way, the attraction within the units, we refer to those as intramolecular forces. Intramolecular forces, or bonds. Okay, in an ionic compound, that's called an ionic bond. In a covalent compound, we call it a covalent bond. That's what's holding the molecule or the ionic compound together. What about between the units? This we call intermolecular forces, or we can call them IMFs. All right. In an ionic bond, we call that electrostatic attraction. It's a very strong attraction, but it's not as strong as a bond. It's an electrostatic attraction, so that it could attract an ionic compound to another ionic compound. And then between molecules, the intermolecular forces can be a number of different things. We always have something called LDF. That's always. Okay. Now, sometimes we'll have something called dipole interactions, and that is only if it's polar. And or we can also have a third type that's called hydrogen bonds. I'm going to put bond in quotes because it's not really a bond. It's not a literal bond. This is an intermolecular forces between molecules. If they're very polar bonds, specifically it's if we have an NH, OH, or FH bonds are present within the molecule. So if we have any of those in the molecule, then we might have a hydrogen bond. So something like water or ammonia, like NH3, or anything that has an FH bond in it as well. Electrical conductivity as a solid, there's none in the solid state of matter for ionic or for covalent. So there's not any electrical conductivity. What about a liquid? Well, an ionic compound, if you melt it, it has a strong conductivity. Covalent, still none. In an aqueous solution, so that means if I dissolve it in water, strong conductivity, if it's ionic. If it's covalent, none. As a gas, none for either one. Gases don't conduct electricity. What about hardness? We say that ionic bonds are usually hard and brittle. With a covalent bond, it's usually softer, and it's a little more malleable or moldable. Melting and boiling point, well, that's based on the strength of their attractions. For an ionic compound, they tend to be usually very high, and with a covalent bond, it's usually much lower than an ionic bond. We got some examples also, so naming some examples of these common substances that are ionic compounds: table salt, Epsom salt. And you could actually probably think of a lot of different things, any form of salt, and there's a lot of other things that are just common spices and such that actually have ionic compounds in them. Okay, to write out a few, we could say NaCl. We could say MgSO4. Now here's a shortcut I want to teach you. If you're doing this in Google, you can find the subscript up here. I don't actually even remember where it is. I can't tell you right off the top of my head where it is, but it's control comma. If you put control comma, it turns it into a subscript, so I can put 4, MgSO4. I can hit control comma again, and that brings it back up to be normal. Okay, CaCl2, so CaCl, and then I can do control comma and write the 2. Just wanted to show you how to do that because you might have to do it at some point this year. But some examples: NaCl, that's table salt; MgSO4, the main component in Epsom salt. Then we have CaCl2, calcium chloride; KBr, it's a common salt substitute; NH4, NO3, that's ammonium nitrate. That's actually a common component in a lot of fertilizers. It's also very explosive, etc. There's tons and tons of ionic compounds. These are just to name a few. If it's a neutral compound that's made up of ions, it's an ionic compound. All right, what about some covalent compounds? There's a ton of those too, but just to name a couple common ones. A common covalent solid would be sugar. A liquid that's really common, of course, is water. And another covalent compound that's pretty common is carbon dioxide. And there's a ton of others. Let's write a few formulas. Common formulas. Sugar is actually C6. I'm going to do the control comma again. C6H12O6. That's actually glucose. Most of the sugar you buy is sucrose, which is C12H24O12, I think, if I remember right. Anyways, CO2, SO2. Sulfur dioxide is a really common pollutant in the air. Of course, we said H2O. That's water. Let's see, N2O. Or NO2, either one. pH3. Etc. There's tons, lots and lots of these. Anyways, that's a summary of the differences between ionic and covalent bonds. These are the most common types of bonds. We're going to go a lot deeper into these types of bonds. We're also going to go a lot deeper into inter and intermolecular forces. but we wanted to do a quick review of this. There's an example down here. I want you guys to work through this. We'll talk about it next class. If you are given 2 samples of solid white powder, you know one of them is an ionic compound, the other is a molecular compound. I want you to propose at least one test, maybe give me a series of things you could do to distinguish between the samples and tell me which one's ionic, which one's covalent. I want you to have some ideas. We'll discuss that at the beginning of class next time. Have a great day.